Next, we will take one problem. The following table gives the number of units produced per day by two workers A and B for a number of days. A, B. 40, 34 കൂടി ഉണ്ട്. So, our question is, should these result be accepted as evidence that two workers equally stable? Our question is, given two samples of workers, given that two samples of workers, we need to test the workers are equally stable or not. Okay, so we take sample 1. So we have only samples, two samples. So we need to use F test, means we need S1. So the sample variance, we need sample variance. So first we find sample variance. So how to find a sample variance? Sample variance, you separately find it out, sample 1 and sample 2. Okay, S1 and S2 you need. So you take first sample, 40, 30, 38, 41, 38, 35. The sum is 222. You got a 222. You take a calculator and you adding this sample values, you get a 222. 222 divided by 6, you get 37. That is a x bar. X bar is an average. So 222 divided by 6 is 37. That is x bar. Next you take x minus x bar. 37. So 40 minus 37, 3. 30 minus 37, minus 7. 38 minus 37, 1. 41 minus 37, 4. 38 minus 37, 1. 35 minus 37, minus 2. Next, x minus x bar square. 9, 49, 1, 16, 1, 4. Next, you take it as sum. Sum of x minus x bar square is 80. Next, you use the variance equation, x square equal to summation x minus x bar square divided by n. So this is the formula for variance, sample variance. So therefore we denote s square. So here summation x minus x bar square is 80 divided by 6. You got 13.3. Okay, 80 by 6, you got 13.33. So first sample variance is 13.33. Similarly, you take a second sample, 39, 38, 41, 33, 32, 39, 40, 34. You take a first sample sum. Sum 296. 296 divided by 2, 3, 4, 6, 8. You got 37. So second sample's mean is 37. Next you take a x minus x bar. 39 minus 37 minus 2. 38 minus 37, 1, 47, 41 minus 37, 4, 33 minus 37, 4, 32 minus 37, 5, 39 minus 37, 2, 40 minus 37, 3, 34 minus 37, 3. Take 8 minus x bar square, 4, 1, 16, 16, 25, 4, 9, 9. You take, add it out, you got 84. So next is 2 square equal to summation x minus x bar square divided by n. Here x minus x bar is 84 divided by total n is 8. So 84 divided by 8. So you get 10.5. So now you got S1 square equal to 13.33 and S2 square equal to 10.5. Next you can use F test. So our null hypothesis H naught is there is no difference. We need to find a stability of two samples. So there is no difference. We assume that there is no difference the two variance. There is no difference between the two variants. That is the null hypothesis. As you take a F statistic, you find it out. F statistic. So we know S1 square is 13.33, S2 square is 10.5, N1 is 6, N2 is 8. So 6 into 13.33 divided by 6, N1 minus 1, 6 minus 1 divided by 8 into 10.5 divided by 7. First you find this value, then you find this value and divided by this ratio, you got, first you get this value is 16 and this value is 12. So 16 by 12, you got 1.33. So our calculated value is 1.33. Okay, calculated F value is 1.33. Okay, next you take degree of freedom. What is the degree of freedom? We already say degree of freedom is N1 minus 1 comma N2 minus 1. Here N1 is 6, so therefore 5, N2 is 8, therefore 7, 5 comma 7. In this case, didn't give level of significance. So you take level of significance is 5%, that is 0.05. And you take F table, you take log table and there as a F table. There is a page, F table. You have level of significance and degree of freedom. Degree of freedom 1, 2, 2, 3. So you take 5, 7. And level of significance. So there is a value. You got a tabled value. That tabled value is 3.97. Here you got 1.33 is a calculated value and table value is 3.97. So calculated value 1.33, table value 3.97. So calculated value less than tabled value. Therefore, our H naught accepted. What is the H naught? There is no difference between variance. Is accepted. That is, this statement is true. That means two samples are not difference. Two samples variance is not difference. That means two workers are equally stable. Okay.